Hey guys, welcome back to another lesson. Today we're going to talk about graphing quadratic functions. I love this. I think it's a lot of fun. I want to begin by looking at some graphs on Desmos. I'm just going to delete this for a second so that graph will disappear. But let's look at this equation. Y equals 2x squared plus 3x minus 5. As soon as I see that squared value, I know that this is not going to be a straight line. It's not a linear function. It's nonlinear because I have x raised to a power of 2. Anytime I see something raised to a power of 2, I know that this is a quadratic function and the graph is going to be this parabola shape. We have two different kind of parabolas. We have the parabolas that open upward. I think of them as the happy parabolas. Imagine drawing two little eyes in here. You have a happy face. And then we have the parabolas like this blue one that I'm getting ready to draw that are sad face parabolas. Imagine again your little eyes been up here and he's a sad face. And I think the way that I correlate this in my mind is that this A value tells me if it's going to be positive. See how this is a positive A value? It opens upward. And when it's a negative value, it opens downward. I could type in a whole big bunch of different equations here. Let me get my lights back on for a second. If I just even get rid of that 2 and just put a positive 1. So let's just look at x squared plus 2x minus 1. It's still a happy face. It's a positive number here in front. It doesn't matter if I change it to 4. It doesn't matter if it's 100. It doesn't matter if it's 12. It doesn't matter if it's 1/2. It doesn't matter what the number is. It changes the shape of the graph, but it doesn't change the fact that it's a happy face. Same thing with this negative. It doesn't matter if it's -5. It doesn't matter if it's -10. It doesn't matter if it's -1/5. Whatever it is, if it's a negative value, it's still a frowny face. It's still opening downward. So that's what this A value in my quadratic function tells me. So I've typed out some notes here to kind of go through with you. We're looking at the quadratic function. It's always written in the form ax squared plus bx plus c. Again, this A value here tells me if it's going to be a happy face when it's positive, because positive people smile, they're happy. Negative people are always frowning, so it's a negative upside down. And C is the y-intercept. So if we go back over here, here my y-intercept was -1. Looky there, -1. Here my y-intercept is -5. Looky there, -5. If I change this to -2, it moves down here to -2. If I change it to 10, it's going to move up here to 10 where I can't even see it. Oh, what in the world did I do? Plus 10. There it is. It's up here at positive 10. Same thing here. We have it at -5, but we can change this to a positive 10. And now it's shifted up here. I could change it to -1. And it's going to cross the y-axis here at -1. So these are important things to look at when we look at our equation. The A tells us if it's going to open upward, if it's positive, downward, if it's negative. The C tells us where it crosses the y-axis. And the next really important thing, this tells us so much information. This vertex is found, it's this high point or this low point on our graph. It's the point right smack dab in the middle. The vertex cuts the parabola. It creates this line called the Axis of Symmetry that runs through the vertex that cuts it into 2 equal pieces. I could fold it over that line, fold it over that point, and the graph is going to lay directly on top of itself. So this point is extremely, extremely important. It gives us so much information about our graph. So what we want to know is how can I just look at the equation if I don't have Desmos here and find the coordinates of this vertex? Well, there's a formula that we can use. To find the x-coordinate of the vertex, there should be a dash in here. To find the x-coordinate of the vertex, we use the equation x equals -b all over 2a. So we take the opposite of this b value. If it's a negative, we make it be a positive. If it's a positive, we make it be a negative. And we divide it by 2 times whatever is here in front of the x squared term. and that gives us the x-coordinate of the vertex. Well, once we know the x-coordinate, it's really easy to get the y because we just plug that value of x back into our equation, solve it, and that will give us the y value. So let's do that. Rather than me just tell you about it, let's put it to practice here. So let's say that my equation is, I don't know, what equation do we want to use? Let's use the one from your book, x squared plus 2x minus 3. So I have here that f of x is equal to x squared, what I say, minus 2x, or plus 2x minus 3. That way, if you're wanting to take notes in your workbook, you can. If not, you can just take them on a scrap piece of paper. It doesn't matter to me. So our formula, we said, is found by taking the opposite of the b term and dividing that by 2 times a. Well, remember, ax squared, what's it doing? Plus bx plus c. So the opposite of my b, well, this is my b. What is the opposite of 2? It would be negative 2. What is my a? Well, the a is the coefficient of the x squared term. We don't see anything there, but we know that there's an understood 1 there. So the coefficient of the x squared term is 1. So I have negative 2 over 2, which is nothing more than negative 1. So that gave me the x-coordinate of my vertex. So now to find the y-coordinate, I'm going to take this x value and plug it in. So I have 1 times the x value, negative 1 squared, plus 2 times my x value of negative 1, take away 3. So negative 1 squared is 1, because negative times a negative makes it a positive 1. So I have positive 1. 2 times negative 1 is negative 2. Take away 3. Notice how I followed order of operations there. I did the squared, then I multiplied it. I did the multiplication. Now I'm going to add or subtract, whichever comes first as we move left to right. So 1 take away 2 is negative 1. Negative 1 take away 3 is negative 4. So y equals negative 4. So the coordinates of my vertex are negative 1, negative 4. So again, we know several things already about our graph. We know now that it's a happy face by looking at the A. We know the coordinates of this vertex are down here at negative 1, negative 4. And we also know that it crosses the y-axis at negative 3. So think about this graphically. We've got negative 1, negative 2, negative 3. There's my y-intercept, negative 4, negative 1. So this is going to go here. The axis of symmetry goes through that vertex. So what that tells me is I can take this point and I can reflect it across. So I have another point now. I know this was negative 1, so this is negative 2 at negative 2, negative 3. So we have a point at negative 1, negative 4, at negative 2, negative 3, and at 0, negative 3. Those are our points that we know so far. So one more time, let's kind of clarify this. We've got the positive A, so it's a happy face. Positive people smile. Positive A makes a happy face. We know the coordinates of the vertex, which cuts my parabola into 2 equal parts, by doing the negative b over 2a, and then taking that value of x and plugging it into the equation and solving for y. And we know the y-intercept by looking at our graph. Then we can reflect that point across. So now we have our parabola. Okay, so a few other things that I would like to point out is that when we have a parabola that is a happy face parabola, think about this. We have a minimum value. It has a low point. This is the lowest point on the graph down here. If I have a parabola that looks like this, it's going to have a maximum value. This is the highest point on my graph. So this is a maximum, and this is a minimum. A minimum value is the low point down here. So when I find the coordinates of the vertex, I have already found that minimum or maximum value. This right here, this negative 4, since it's a happy face, I know that this is the minimum value. Negative 4 is the minimum. So finding the vertex, I know several things. I know the coordinates of the vertex is, what is it, -1, -4. I know the y-intercept by looking at the equation. The y-intercept, that's a C, not an E. Intercept is at 0, -3. I can reflect that point across, and I know the minimum value of my function is -4 because it's the y-coordinate. Knowing that A was positive and it was a happy face, I know that has to be the lowest value. If A had been negative, then the y value of my vertex would have been the maximum value. So one more time, the last part of this says, and the y-coordinate of the vertex is found by plugging the x back into the original equation. This y value is also the minimum or the maximum of the quadratic function. It depends on if my a was positive or negative. If a was positive, the y value is a minimum. If a is negative, the y value is the maximum. And that sums up this lesson.